Hello all, welcome back to my devlog where I make a game engine and try to make a game in it. March and April were spent starting improvements to the art and visual layout of the game. Up to this point, the engine has done the game logic and drawing on the same thread. It was done this way for simpler code in the beginning stages of the project. However, this decision came with a few problems. The biggest one being if a frame took longer than 16 milliseconds to draw, the entire game would slow down as a result. This is a catastrophic behavior in time-sensitive modes and cannot happen in the final game. The solution I chose here is to move the drawing into its own thread. Now, instead of the game thread drawing the blocks, it puts draw requests into a list. And when a frame is done, the list is passed to the render thread for the actual drawing. The render thread will only draw the most recent list that it has received. This means that if the game thread runs faster than the render thread and lists get backed up, older queued lists will be ignored, resulting in dropped frames. The end result is that the game thread will still be able to run at full speed, even when rendering takes too long. While doing this modification, I wanted to verify the optimizations that I did several videos ago were working as intended, so I exported the assembly for the draw function to verify. They were working as intended, but there was something else that caught my eye. When I first made the drawing code that handled alpha blending, I made some unoptimal code hoping that the optimizer would know what I was doing and make it better. That was not happening, and it was just compiling the code verbatim. I decided to use this as a learning experience and attempt to use SIMD to optimize the code. SIMD stands for Single Instruction Multiple Data. It is a feature in modern processors that does math on multiple values at once instead of one after another traditionally. And this would allow me to do the blending function on all three components at once. SIMD does not have all the operations that I needed for the original blending function, so it needed to be rewritten. The old function is a standard linear interpolate function, where you take the difference between two values, multiply it by the alpha, and then add it to the base value. The new function is based off the mean or average algorithm, where you add the two numbers together and then divide by 2. I modified it so that the values are multiplied by the alpha and inverse alpha. This way, it is like finding the average of 255 values, and the result should be the same as the old function. I coded a test program here to verify that they are the same. I mean, if they are close enough that people won't notice. And the test passed. To make this a bit faster, I changed the divisor to 256. Dividing by 256 is mathematically the same as bit shifting to the right by 8, which is a much faster operation. With that done, the SIMD code was written and tested, and 60 milliseconds per frame. That went the wrong way. Well, this is on a debug build. What would happen if I compiled it in a regular build? It comes to 7 milliseconds per frame. That's a bit better, but before I called it good, I wanted to test the new blend algorithm without SIMD. Here are the results of the three draw types. The SIMD code is faster than the old way, but only if I do not run it in debug mode. However, the new algorithm without SIMD saves even more time over the SIMD variant. This is the one I ended up sticking with. To make good use of the optimizations, I took another look at the cutscene state from the story mode. I was not liking the way the characters were coming along, so I decided to switch gears and go with the visual novel style. You can see the sketches here on screen. For the final look, I wanted to have the 1 pixel wide lines that are reminiscent of the games from the 16-bit era. Problem is, I am not an artist, and do not feel like spending all the time making each perfect line by hand. Time to see if I can emulate good art with programming. For the 1 pixel line, I made a framework in college that could draw lines like this. I resurrected it and modified it to create a list of Bezier curves to make up the strokes, and ooh, that's a lot of jaggies. Going back to something more simple, it now creates a list of straight lines following the cursor as I draw. That's a little better, but it still has the jaggies. To be rid of the jaggies, I thought about detecting when the curves I draw change directions and draw smooth lines between those points. The detection part is not that hard. For each point in the line, I do 4 comparisons, and the direction is different when one of them changes. Drawing the smooth lines is proving to be difficult. I have tried various things, but none of them ended up working, and I ran out of time for this milestone. Thank you all for watching, and see you all next time.